This is section 6.6 part 2, graphing linear equations. In the last chapter, we learned how to graph points from an equation, a general equation of a linear line. In this chapter, we're going to how to calculate the slope of a line and how to write the slope-intercept form of a line. Once we know the slope and the y-intercept of a line, we're able to graph the line. The slope is a measure of the steepness of a line. The slope of a line is the ratio of the vertical change to the horizontal change for any 2 points on the line. So our equation for slope is the vertical change divided by the horizontal change. We sometimes call this the rise over the run, and it's sometimes stipulated as the following: the change in y over the change in x. If we have 2 points, suppose point 1 is equal to the point x1, comma y1, and point 2 has the numbers x2, comma y2, then the slope m can be determined from the 2 points y2 minus y1 divided by x1, x2 minus x1. So again, m is the rise over the run. So for a positive slope, the slope rises from left to right. That means that as x is increasing, y is also increasing. That means that slope is greater than 0. So here in this particular case, if we see a line in this form, it's a negative slope that falls from left to right. This means as x increases, y decreases, and that means that m is less than 0. A horizontal line which neither rises nor falls has 0 slope. Here, m equals 0. There is no slope. And finally, the slope of a vertical line is just undefined. So in this case, m does not exist. There is no slope here. So suppose I have the following 2 points. Find the slope of the line through the points -1, -3, and 1, 5. The solution is, of course, the slope is equal to the formula y2 minus y1 divided by x2 minus x1. When we plug in the y values, we have 5 and a minus 3, so 5 minus a minus 3. And on the denominator side, we have the x's, x1, which in this case is 1, minus a minus 1. And therefore, we have 5 plus 3 divided by 1 plus 1, which is 2. So 8 over 2 is equal to 4. Our slope for a line going through the points -1, -3, and 1 and 5 is equal to 4. So the slope of 4 means there is a vertical change of 4 units for each horizontal change of 1 unit. The slope is positive and the line rises from left to right. In other words, we go up 4 and we go over 1. So our line looks like this. So we have our point 1, 5, which is here. We have the point -3, -1, -3, which is right here. And if we go up 4 and over 1, we see we have the y-intercept at 0, 1. If we go up another 4, 1, 2, 3, 4, and over 1, we're at the next point, which is 1, 5. Notice our horizontal change is just 1 unit, and our vertical change is 4 units. So now we have what's called the slope-intercept form of the equation of a line. Y is equal to mx plus b, where m is the slope of the line and 0b is the y-intercept of the line. Remember from the last section that the y-intercept is that point which crosses the y-axis. To graph the equation by using the slope and the y-intercept, first we solve the equation for y to place the equation in slope-intercept form. Secondly, we determine the slope and the y-intercept from the equation. Thirdly, we plot the y-intercept, and in fourth, we obtain a second point using the slope. We draw a straight line through the 2 points. So we're going to write the equation in slope-intercept form. Notice we have the general form in part A. Write 4x minus 3y equals 9 in slope-intercept form. Part B, we're going to graph the equation. So our solution is we start out with 4x minus 3y is equal to 9. We subtract 4x from both sides. The reason why is we want to isolate y on the one side of the equation. And we get, obviously, this next equation, negative 3y is equal to negative 4x plus 3. Now we will divide both sides of the equation by negative 3. When we do that, we get this operation, and our final result is y is equal to 4/3 x minus 3. So in this particular case, we know the slope is 4/3 and the y-intercept is at 0 minus 3. So knowing this piece of information, we now can plot the intercept, which is at 0 minus 3, which is there on the y-axis at minus 3. And now the slope is 4/3, which means we go up 4, 1, 2, 3, 4, right? So there's 4 units up, and now we go over 3 units this way, and we get our next point. The next point on the line, obviously, is 3, 1. Notice that this point also solves the equation for, if we put 3 in, for x, we're going to get 1 for y. Now we're determining the equation of a line from its graph. We determine the equation of the line. So here we have two intercepts. One is the y-intercept is at 0, 3. So b is equal to 3. That's certain. Now we look at the x-intercept. It's at 2, 0. So that point is we go down 3, which is a minus 3, and we go over 2. So this is a minus, the slope then is a minus 3/2. Now we know the equation, the formula for the y-intercept. Y is equal to mx plus b. We just plug in the results of our looking at the equation on the coordinate system, and we see that the slope, which was a negative 3/2, so we use that, negative 3/2 x plus 3. So that's our equation. Our equation is y is equal to a negative 3/2 x plus 3. So now we're going to graph horizontal and vertical lines. In the Cartesian coordinate system, a graph A, y is equal to 2, and B, x is equal to a negative 3. Well, for part A, for any value of x, doesn't matter because x is not included in this equation here. So y is always at 2. So it's a horizontal line because x can be any number, but y is set at 2. For x is a negative 3, y can be any number, but x is at negative 3. Here we have a vertical line, and of course we don't have a slope at all. In graphing equations in this section, we label the horizontal axis the x-axis and the vertical axis the y-axis. Each equation we can determine the value for y by substituting in the value of x. Since the value of y depends on the value of x, we refer to y as the dependent variable and x as the independent variable. We label the vertical axes with the dependent variable and the horizontal axis with the independent variable. So the summary of chapter 6.6, we learned how to graph points x, y on a coordinate system. We found points from an equation ax plus by equals c by just for a particular x we found a particular y. Then we found the slope of a line from 2 points where the slope m is equal to y2 minus y1 over x2 minus x1. Then we graphed a line from the slope-intercept equation, which was y is equal to mx plus b. And finally, we also, in this chapter, found the x-intercepts and the y-intercepts of a particular equation. Well, that concludes our chapter 6.6, and in the future we'll be looking at different types of equations.